Right, so let's get back to the delights of ISO 8859. Whenever we saw a ISO 8859-1, assume that it's code page 1252. And so this was a fairly revolting kind of mess. And so the International Standards Organisation went back again and said, right, we need to do something about this. We need to get rid of this idea of code pages because it's killing us. Could we come up with one universal code page for every language? Something that Microsoft and IBM and national governments can't go and mess up. But I'm sure you know exactly what slide I'm going to show next, which is how Microsoft managed to mess that up. The principle behind UTF 16, and this crops up in a few different places. JavaScript, for example, has this problem. If you're doing any defense stuff in Ada, you'll see they talk about wide characters, a wide char being 16 bits. 16 bits gets you 65,536 different letters. That should be enough for anything written in the world. So we'll just encode everything in 16 bits and life will be good. There's only one teeny problem with this. Anyone want to take a little guess here? This is how I can tell whether people have read the slides ahead of time or not, because you know the answer. Any guesses? You can see that it's going to be obviously bad, but it's actually worse than that. I had an argument with a Chinese classic scholar on this question, and he said, no, I mean, you can make up a new character just because the other person doesn't understand it. Doesn't mean it's not a valid Chinese character. You knew what you were talking about. But anyway, the GB 18030 standard says there's 87,000. And that's just Chinese characters, because of course a Chinese character might look exactly identical to its Japanese counterpart, but they might mean completely different things. And they might have different sort orders. They might have all sorts of stuff like that. I'll talk more about that particular standard later. No, suffice to say, it's bigger than 65,000. So immediately they ran into a problem. And so the solution to this is, well, we're going to have varying width encoding. At the beginning of the talk I said, you've got 100 bytes. You don't know how long that is in characters, because unless you know the encoding, it doesn't tell you anything. Varying width encoding is the idea that, okay, well, we'll just have a stream of bytes, and maybe the first byte has the information that describes a whole letter, and then the second, third, fourth, and fifth bytes might be the next emoji that's being displayed, and then you might have 2 bytes to do something else. So the implication is that the length of the string doesn't match the length number of letters, doesn't match the length number of bytes. This was utterly revolutionary when people proposed it, and was absolutely terrifying. You will still find programs to this day that assume that the length of a string is the length of bytes. If you're programming in C and you ask for the strlen function, strlen counts the number of bytes until you hit a null character, which has nothing at all to do with how many letters wide that's going to be. Not only does it not tell you how many letters wide that's going to be, but on my list here I have somebody who does speak Arabic. I didn't see who it was. Of course, with Arabic you've got, I'm doing my consonant, and then the vowel sits over the top of it. It was 2 letters, there's the consonant and the vowel. How much space did it take up in the terminal? 1. How many letters are there? 2. How many bytes did it take to encode that? Probably 4. There's just no connection between these 3 things at all. You have to decode, and then you have another problem, which is the presentation layer. UTF 16 is the standard for a couple of different common platforms. Most Windows boxes default to UTF 16. So when you create a file, the file name is encoded in UTF 16 on disk. So if you are file sharing from one Windows box to another Windows box, the files will be transferred in UTF 16 format, because that was going to be the solution. And JavaScript. Early 90s era, everyone thought UTF 16 was going to be the solution to everything, and thus you get this.